Step 3 is for us to determine the critical value and to draw the rejection region. The critical value is a value that you will either find on one of your statistics tables or using your calculator. And the critical value depends on two things. It depends on the type of hypothesis test. So we've talked about how there are several different types of hypothesis tests, and we'll look at those in more details in the upcoming lessons. So it depends on the type of the test, and it also depends on the level of significance. And the level of significance is denoted by alpha. You will always be given alpha in your hypothesis test. And so let's say that in this problem for scenarios 1, 2, and 3, that I'm telling you to use a 0.05 level of significance. The rejection region also depends on two things. It depends on, the rejection region only depends on one thing. It depends on whether the test is a right tail, left tail, or a two-tail test. And to determine what type of tail test this is, you will look at the alternative hypothesis. So you look at HA to determine whether this is a right, left, or two-tail test. I will remind us of what our HO and our HA is. For scenario 1, the HO was that mu is equal to 43, and the HA is that mu is less than 43. So looking at the HA, the inequality points to the left. So we always write our population symbol first. So we write mu first, and we have that mu is less than 43. That inequality points left, and so that tells us that this is a left tail test. Now that we know that this is a left tail test, we are able to draw our rejection region and determine our critical value. So I'm going to be drawing a bell curve. And in my bell curve, I need to make sure that the area to the left of where I put my critical value is equal to alpha. So I'm going to put 0.05 area in this region here on the left. I've drawn that on the left side of the bell curve because this is a left tail test, and I'm using 0.05 because that is my level of significance. The Z value that will land right here, that will be my critical value. So I need to find the Z value that has a left area of 0.05. That's what we're going to be looking for now, and that will be our critical value. Now when I look at the statistics table, looking for the closest area to 0.05, we see that we have at negative 1.65, we get 0.0495, and at negative 1.64, we get 0.0505, which are both 0.0005 away from what we need. And so we are going to take the average of those two Z values. So we are going to average together negative 1.64 and negative 1.65. Because both of those Z values are equidistant from the area that we are looking for. So when we add those together and divide by 2, we come out with our critical value of negative 1.645. So that is the critical value that we will be using. So our Z value here is a negative 1.645. So we have determined our critical value. That is our Z sub C here. You can call that Z, or you can just call that Z sub C. The C stands for critical. And our rejection region is the purple shaded area with an area of 0.05.